Hi, my name is Houssein, and today I'm going to be talking to you guys about solubility graphs. So there's four main things that affect the solubility of a substance. The first one is going to be temperature. And generally, as the temperature increases, so does the amount of solute dissolved in the solvent, up until a certain point, and that is called saturation. So, as temperature increases, so does solubility. The second thing is going to be surface area of the solute. So, here, this is going to be the surface area, and this is going to be the amount of grams. And as you increase the surface area of the solute, the solubility is going to increase. Now, this is because there's much more surface area for the solvent to attach to the solute and dissolve it, in a sense. Third thing is going to be the volume of the solvent. So, as volume increases, so does the solubility. And this is because, can you see it? Okay. Don't worry. And just to show like a quick example of this, if you were trying to dissolve 10 grams of salt in 5 milliliters of water, or 10 grams of salt in 1 liter of water, obviously it's going to dissolve much faster in the 1 liter of water because the saturation threshold is much higher than the 5 milliliters of water. And the last thing is the amount of mixing that you do. So, if we could describe mixing in on a graph, which is labeled out as M, and this is grams, then the solubility is also going to increase. And this is because all the molecules are hitting each other and breaking apart, and that will just make everything dissolve faster.
Alright, hi, my name is Chris, and I'm going to explain to you or talk about the solubility table. So it's essentially a table that shows you different compounds that we're often going to see in solution chemistry, and whether they're soluble or non-soluble. And it's really going to come in handy later on, so I suggest memorizing it. It's not a lot of fun, but it could be necessary. So there are a few things that affect the solubility of a compound, and one of these that we're going to see a lot is electronegativity. So if within a compound we see that certain ions are attracting the electrons closer to them because they're more electronegative, we're going to get dipoles within that compound. For example, with NaCl, the sodium ion is going to not have the electrons as often, so it's going to become slightly positive, and the chlorine is going to become slightly negative. And this really increases its solubility, because when we have a solvent like water, which is also has dipoles, negative and positive, we're going to see that negative, positive, that attraction between those two dipoles. So, for example, the oxygen is going to pull away the positive sodium ion because of that attraction between those two dipoles. And the same how hydrogen is going to pull away the chlorine. So that dipole attraction is what's going to ultimately split the compound and make it really soluble. So on the flip side of that, we could see a compound that doesn't have any dipoles, and it wouldn't be very soluble. Another thing that affects solubility that could be behind some of the rules on the table is surface area. So if we see that a compound has a very large surface area, it's not going to easily it's not going to be easily soluble within a solvent. Whereas this small compound, for example, like NaCl, it has a low surface area, so it's going to be very soluble. So these sort of rules, it's good to have them in your head when you look at the table, because those are the sort of things that are going to affect what's soluble and what's not soluble.
Thank you.
Thank you.